So analysis of variance, or ANOVA, has a couple different uses. One of them is comparing multiple means. So we're just going to go over this really quickly just to kind of give you a sense of it. But if you want more details, you can look in our textbook in Chapter 9. Okay, so in this example, researchers were conducting a study of 4 popular diets: Atkins, Zone, Learn, and Ornish. And they randomly assigned 311 female volunteers aged 25 to 50 in a certain BMI range to one of the 4 diets. At the end, they calculated the change in BMI. So a negative number means that their BMI was reduced for each of these women, and compared the results. So we are looking at like a before and after. We're looking at change in BMI. So there is kind of a paired component to it. But this is basically just a quantitative response variable. Right? We're looking at the change in BMI, and that's quantitative. Our explanatory variable is categorical because we're looking at the 4 different diets. So it's categorical, and more specifically, it is not binary. So in Chapter 6, we saw that you can use a 2-sample t-test when you have a quantitative response and a binary explanatory, but a 2-sample t-test, that only works for 2 groups. So if you have more than 2 groups that you want to compare, that's when you would use an ANOVA. So you can see some of the jump output here. So these all have negative values for the mean. So that means that BMI was reduced on average for all 4 of these. You can also see the standard deviations. And we're trying to decide if there's actually a difference between these 2 diets. So take a second and think about how we're going to state these hypotheses. So first of all, what symbol do you think we're going to use? Would it be pi or mu or beta? And then how do you think we're going to phrase it in terms of equal signs and inequalities? So pause the video here for a second and think about how to state the hypotheses. So our response variable is quantitative, and we're trying to compare the means for each of these diets. So we're going to state our hypotheses in terms of mu. So the null hypothesis will be that mu is the same for all of these groups. So we always have equal signs in our null hypothesis. So the mean for Atkins is equal to the mean for, let's see, what's next? I guess I'll go in alphabetical order since that's how they are in the graph. Learn is equal to the mean for Ornish is equal to the mean for Zone. So all this means is that all the diets are equally effective. So we're not necessarily saying that they're not effective at all. We're just saying that there's no difference between the diets. They're all equally effective. And then for the alternative, we've seen this before where we have multiple parameters being compared. The alternative is just going to be that at least one of these is different from the others. So at least one mu is different from the others. So again, not going into the details of how it's calculated, this is our standardized statistic. This is an F statistic. And then this is our p-value, the probability of getting that F statistic or larger. So our p-value for this one is 0.0106. So we would say in that case that we have strong evidence to conclude the alternative. And in this case, it would be strong evidence to conclude that at least one of the diets is different from the others. So at least one of the diets is different. And when we say different, we mean different in terms of BMI reduction. So we're not looking at anything else here, like how well people can adhere to the diet or other health benefits or anything like that. We're just looking at BMI reduction here. So on its own, that's not really a satisfying conclusion because that doesn't tell us which of the diets works best or which of them are different from each other. We're going to need some way to follow up on that. And there's a couple of different ways to do it, but one of them is to use confidence intervals, sort of similar to the way we did when we were comparing proportions after a chi-squared test of independence. So this is part of the jump output. This is called an ordered differences report. And each row here is looking at a different pair of treatments. So like for this first row, this is showing the mean for the Zone diet minus the mean for the Atkins diet. And they're actually ordered from the biggest difference down to the smallest difference. It also gives us the standard error of the difference. It gives us the endpoints of a 95% confidence interval. So where it says lower CL and upper CL, this is the 95% confidence interval, and then it gives us the p-value. So take a look at that output and see if you can figure out which of the diets are significantly different from each other. So there's two ways that we can use this output, but they're going to give us consistent answers. One is that we can look at the confidence intervals to see whether or not 0 is included. So if we look at these first three, we can see that 0 is not included there, that we have positive numbers on both sides. So that means that we've got a positive difference between each of those pairs. We can also look at the p-values and see if they are large or small. So in the cases where 0 is not included, it also ends up giving you a small p-value. So looking at which comparisons give you those values, we can see that these are the ones where we're comparing the Atkins diet to the other three. So this is telling us that the Atkins diet is significantly different from the other three. So in each of those cases, we can see that the confidence interval does not include 0. So these three confidence intervals don't include 0. And all of these also have small p-values. So p-values less than 0.05. And it can be a little bit tricky to figure out the direction here. Honestly, I think instead of working from the ordered differences report, it's really easier just to go back up to the graph or up to the means. So if we look at the means here, we can see that the lowest negative number is for the Atkins diet. And remember, negative numbers mean that there was a reduction in BMI. So the Atkins diet leads to the largest reduction in BMI, and it's significantly different from the other three diets in this study. And again, just want to reiterate that this was a study looking at a very particular thing, BMI reduction among a certain category of people. So you wouldn't want to recommend this diet based just on this study. All we can say here is that for people like these, if we can generalize to a population, then the BMI reduction is going to be smaller for the Atkins diet. There may or may not be other factors that should be considered.